Alright, welcome back everybody to another video, and in today's video we will be talking about how to solve a linear quadratic system. So the question says, determine the coordinates of the points or point of intersection for the following linear quadratic system algebraically. So we're given a quadratic function right here in standard form, and we're given a linear function. So it says determine the point or points. That's why there's those brackets there. So really, when you think about it, when you have a quadratic function, it could look like this, and you could have a linear function that looks like this. So you'd have 2 points of intersection. But you could also have a linear function where it only intercepts, if I could draw this properly, only intercepts maybe 1 point, let's say here. Or you could have it where it doesn't even intersect this quadratic function at all. So what they really want us to do is to solve to see if there is any points of intersections, and if there is, what are those points of intersection. So the first step in solving this is that you would set these equations equal to each other. So what I will do is set x squared plus 9x minus 11 equal to 5x plus 10. So I set this quadratic function equal to the linear function because I want to know what x values are these two functions equal to one another. So where do they intersect? So I'm going to move everything to one side. I'm going to move everything to the left side. So x squared plus 9x. Move the 5x over, becomes minus 5x. Minus 11. Move the 10 over, becomes minus 10. And this is all equal to 0 now. So let's simplify this. X squared 9x minus 5x is plus 4x, and then negative 11 minus 10 is minus 21, and this is all equal to 0. So now we can see that we have a quadratic function in standard form here that I could factor. So I'm going to factor this. Product is always the product of a times c. So 1 times negative 21 is negative 21, and the sum is positive 4. So I need to think of two numbers that multiply to negative 21 but add to positive 4. So that would be 7 and negative 3. 7 times negative 3 is negative 21, and 7 plus negative 3 is positive 4. So we're good to go here. So it's going to be x plus 7, x minus 3 equal to 0. Now I can solve for these x coordinates. So in order for this equation to be true, for this side to be 0, this has to be 0 or this has to be 0. So what you're going to do is set each factor equal to 0 and solve. So this would be x equals to negative 7. It's your first answer. And this would be, move the 3 over, positive 3. So these are the two numbers that make this equation 0. So these are our two x coordinates, which are the x coordinates of the points of intersection of this linear quadratic system. So what you're going to do is you're going to actually want to plug these x coordinates back into either one of these equations. So I'm going to pick this linear equation, which is y equals 5x plus 10. I'm going to pick this equation because it's easier to plug these numbers in than into the quadratic one. So plug in the 7 here, negative 7, so y equals 5, and then you're going to do the times the negative 7 plus the 10. So this would equal, well, that would be negative 35, which is negative 35 plus 10, which is negative 25. So your first point of intersection is negative 7 and negative 25. And then you can plug in this positive 3. So let's just keep it all the same here. Plug it in for x plus 10. Well, this is going to be 15 plus 10, which is positive 25. So our second coordinate of intersection is 3 and positive 25. So these are our points of intersection, and what I'm going to do is I'm going to quickly go over to Desmos, and I'm going to plug these two equations in, and I'm going to show you what the graph will look like here. Alright, as you can see over here on Desmos, I've plugged in the quadratic function is in the red, and the linear function, which is in the blue. And as you can see, the points at which the linear function intersects this quadratic function is -7 and -25, and +3 and 25. So yeah, so this is how you would solve a linear quadratic system of equations algebraically. Thanks for watching.